Hey everyone, welcome to Cloud Masters. I'm your host, Matan Bordo. I'm joined by my co-host, Sam Clark, and this episode is for the data folks out there. Whether you're a data engineer, data admin, analyst, platform manager, we're going to talk about fine-tuning your data platform with BigQuery and beyond. We're going to talk about some other tools that kind of make up your data platform. I'm joined here by Sale Matthews, return guest, and Philip Heinrich. Before we jump right into things, Sale, Philip, why don't you just give a quick blurb about what you do at DoiT?
Sure. Yeah, here, DoiT. I am a cloud architect, essentially focusing on data, helping out most of our customers, any sort of complex issues they have, mostly on the data side of things. I focus almost exclusively on GCP, BigQuery being the biggest focus of it. So if you've run across anything I've written or my next presentation I did next, it was all on BigQuery. So that's about what I focus on nowadays and just helping customers out on managing BigQuery.
My name is Philip, joining in the same capacity as Sale. I'm also a data architect on DoiT's side, specifically GCP. I've been doing BigQuery for ages, for at least years now, helping customers to get the most out of BigQuery, helping them architecting, but also building platforms, but also helping them to bring down the cost in long term. So that's what we are here for.
Yeah, for anyone not familiar with these two, we've done tons of BigQuery related webinars, Q&A sessions together over the past year, especially in light of these the BigQuery pricing changes that happened in July, the new autoscaler, and figuring all that stuff out. Sale, you had a really popular presentation at Google Next this past August, I think it was. So much so that they asked you to do a second session on short notice, I think the next day or 2 days later.
Yeah, it was a week before is when they asked, so can you do it? And so, yeah.
So we're here to cover some of the topics that you discussed there, of course, with the added expertise of Philip. But first, maybe we can clarify what you mean by data platform and why are we focusing on BigQuery, not exclusively, but why is the focus on BigQuery in the context of data platform?
Just to answer why BigQuery. BigQuery is probably, I would say, number 2 or 3, the largest product GCP sells. I think internally in DoiT, we did some analysis, and I think it was number 3 for us. And so it is up there, is one of the largest, I don't want to use the word SKU, one of the largest services that Google does and sells. And I'd be very surprised if it wasn't up there number 1 or 2 for their revenue, probably number 2 for revenue behind compute for them. And so it's used by a lot of customers. I mean, I would say probably 80% plus of DoiT customers use BigQuery in some capacity. Or I say DoiT GCP customers, not just DoiT customers. But because we are an AWS partner as well, if we want to keep that into the final one here. And to answer about what a data platform is, I mean, I would say personally that a data platform is anything from the beginning to the end, anything that serves data, any of your data sources, anything in the middle that picks up where your data might be, including like message queues. So you've got Kinesis, PubSub, RabbitMQ, ZeroMQ, Kafka, etc. Anything in there, as well as anything in your ETL pipeline. If you have Airflow, Apache Beam, or Dataflow, Matillion, anything along those lines. SSIS, if you want to go old school with .NET World, anything in the middle there, including up to your databases, Cloud SQL, you may have MySQL, Postgres, RDS, anything along those lines, maybe Mongo in there. Anything in that, as well as your final sources, which might be BigQuery. You might have some BI visualization tools. You might have an application that serves some of this data up for maybe monitoring or maybe giving real-time analytics. All that, I would say that would be anything involved in there is your data platform. It would be my opinion on the matter. And that's kind of what we're trying to aim for in this.
I think, and for me specifically, data platform means not only having a transformation tool, not only having a data warehouse that covers parts of the business. I would say data platform covers more than transformation, especially source data integration, and then also the data products part, basically delivering the data to business. And I think BigQuery was initially, or when BigQuery launched, they did a pretty good job in actually integrating their own data into BigQuery as well. So talking about Google Analytics, of course, but also all the ads data, they could natively export it or also import it into BigQuery, which is, I think, for a lot of the marketing companies out there, especially e-commerce companies as well, I think that was already a head start for them because they had the data already being integrated, and they haven't had to think about how do I integrate Google Analytics data into my data warehouse, because it was already there and they had to cover just the transformation part, and then grew from this marketing warehouse into like a real data warehouse. And I think that's why Google got so many like kudos for building BigQuery initially, because they already had all those integrations lined up, and then also because it's such a good product to deliver data as well. And I think they are just building more and more features on that, including the data clean rooms nowadays, where you can also keep the data in BigQuery to deliver it to your business, to your BI tools and so on. So in my opinion, BigQuery does way more than a traditional data warehouse because it fully integrates on the source, but also on the destination side of the data.
So now I have things a little bit more clear. It is kind of what I thought this would be about, where we're talking about not just best practices with BigQuery, if it's playing a core role in your data platform, but also we're going to go over some of the additional parts of your data platform, go over how to make it play well with BigQuery so that you have an efficient running data platform. So we're going to be talking about things like storage, right? ETL, etc. I know from your session, Sale, that before you jumped into some of this stuff, you said something. I don't know. I don't think it's that controversial. I think it's just kind of a fact of life, where sometimes a particular cloud service is not going to be relevant for your needs, and so you posed pretty early on, BigQuery, in terms of a usage strategy, BigQuery may not be suitable for your use case. It might not be the correct product. So maybe you could shed more light on that before we go into meat on the topic.
Yeah, BigQuery. I know Google's marketing and a lot of other places have said BigQuery should be the end all be all, and then, which sounds great and all, but then you realize that BigQuery, it is a data warehouse, which is not a database. It is, for all the technical folk out there, it is an OLTP database, or an OLAP database versus an OLTP database, which is your traditional MySQL, Postgres, something you're going to talk to for an application. OLAP stands for online application or online analysis processing. And that means it is based on doing analytic workloads. It can do things where you're doing aggregates, you're looking at sales numbers, you're building reports, you're doing things like that. You're not writing data and reading data every second to it. It is great for massive workloads that we're going to have a ton of data doing something for. So, but unfortunately, a lot of customers, and in the past, before the pricing changes, a lot of customers realize it's cheap. It's really cheap. I'm going to go ahead and just use this for my application database. So a lot of customers have done that. And unfortunately, due to these pricing changes, they're realizing that all of a sudden it's gotten expensive and I need to real quickly switch. So it is not something you want to use for your application database. And especially with these price changes, it may not be the best use case for everything going forward that it had been in the past, just because it was so cheap for so long. And after price increased, it kind of became what it should be, what the technical documentation in Google says it should be. And even with the price increase, it may not be all that nowadays based upon how much you want to spend. So that's just my little 2 cents on what it's for and what it's not for. So it's definitely not the silver bullet that a lot of marketing material has put it for so long.
Yeah, I mean, of course, for the use cases, I think that Philip described that it's great for. It's what it was. It's how it became so popular straight from its release. So it just really depends on your use case. I think no shame in saying that. Now, on to the main topic. Around the time that the BigQuery pricing changes were announced, around the time that the autoscaler was released, there was this new thing called, there was a new SKU that I think people were seeing in their billing that was affecting them. And maybe you could explain what that is. I think is something around Dataplex. And maybe you can explain in the context of data platform, where does Dataplex fit in and why are people using it even?
Oh, Dataplex. I think we could probably have a full session only on Dataplex nowadays. I think Dataplex is for folks that are just joining the GCP ecosystem. There was a data catalog on GCP's side or GCP data catalog offering, let's say, which got a little bit of love, honestly, from the PM side or engineering side, but never made it really into a full data governance product. And Google actually catched that, and they started building more and more products around data lineage, data cataloging, metadata retrieval, metadata storage, and all those products that are actually needed for making a data warehouse governable, let's say. So that's why they came up with Dataplex. Dataplex has like many new features that are not coming from the data cataloging landscape only. For example, like automatic profiling of your data. So you could see what kind of distributions of data you have in your tables automatically. There is a lot of data quality checks that are actually going into Dataplex nowadays as well. And the SKU that you're mentioning is, I think it's a little bit unfortunate because when the Dataplex offering got into preview, they basically offered the service free of charge. So people just sign up for the API, turn it on, and use the tool for, I think it was probably 3 months at least, where you could use the tool free of charge, including all the lineage, including metadata profiling and so on. And then they've sent out, I think, with a couple of weeks notice, actually, an information saying, yeah, we are going to bring this product into GA. And as of that, we are also going to charge for that API. But as you all know, you just turn on an API and then probably forget about it, or you even turn it on and then you're not the one who's actually paying for it in the long term. And then we got customers screaming and say, yeah, why is this actually so expensive? And the reason for that is probably quite obvious, because it's basically profiling tables, and it's a change on the product, on the project level. So all the tables, all the data sets, and then depending on the large your data warehouse actually is, you could have been actually charged for that quite hefty, because also like intermediate actions probably coming from data flow. So whenever something changed the tables, that was actually then also being scanned again. So yeah, long story short, it's something that you should be curious about. I mean, Dataplex will not go away, I would say, because it's built into BigQuery natively, but also into PubSub, into Dataflow nowadays as well. So it's more like a helicopter that is flying on top of BigQuery. But be careful with activating it without actually considering if you need it or not. I think it's the QLDR on that.
We probably should note that the SKU that generally is appearing that customers are seeing is called Dataplex Premium Processing. So if you want to go through your billing data and search for that generally means you have Dataplex or Data Catalog turned on. And it, like Philip said, auto scans. And we've had a couple of customers raise that alarm with us recently.
What have those customers done? Is it just kind of, okay, let me eat this cost, or can they do anything about it to reduce it? Or is it just keep it on or keep it off?
I would have started with it depends, honestly, because if you have a data governance tool and you already have data lineage and you're already paying a hefty price for another tool already, you would probably turn it off and not use it, because I think it will probably not generate any additional insights if you already have it in another tool. But if you're up to data governance, if you're up to data lineage, and this is the first time, or you haven't had the chance to actually look into other tools on the shelf, I think customers stick around with that. And we actually have training offerings around Dataplex as well. So we see more and more importance coming into Dataplex. So if you're a DoiT customer, shameless plug here, reach out to us. There's training available, of course. But yeah, there is no one fits it all answer, unfortunately, Matan.
So I'll second that. And I work with one customer that was a large retail customer that they're using data catalog, but not anything else. They were able to turn off the overlying Dataplex API, just turned on the data catalog API, which still does the scanning, but their cost went down by about half on that particular SKU just because they hadn't turned on everything and they just were using data catalog for a few things. So,
So I mean, I guess we're coming back to one of the things we called out on another podcast with you, Sale, is if you don't know what you're turning on in your cloud, then you're in trouble, right? They're looking for
yes,
those red flags, looking for that stuff like we just wanted to test this for 5 minutes, and I mean the classic people talk about obviously is doing a select all on a BigQuery, and charging for terabytes and terabytes of data scanned. But yeah, if you're turning on APIs and not remembering that, suddenly you get a bill and need to look after what you're doing.
yes, definitely. And just remember, Dataplex is used by a lot of other things, so just be wary of turning on something that happens to have says you need to turn on Dataplex as well. Just make sure you are making sure that you actually need it, because that was the case on one customer I worked with, that they turned it on for some other feature that was recommended and wasn't really needed. And they were starting to get an extra couple $100 a month tacked on their bill because of that. And they turned it off and nothing broke.
I want to take a step back and go from BigQuery down to ancillary services you may use with it, plug into it with your data platform. But in general, what would you say are like some good strategies for reducing compute usage in BigQuery? Because I know just from working with you throughout this year and several BigQuery events, that compute has become ever more important to pay attention to, even more than it was before these pricing changes. And so, dealing with the autoscaler, you have additions now. We haven't. I'm focusing on compute because I know there's also compressed storage, which we'll get into, and that's a really great thing. But in general, what would you recommend to anyone listening who's looking to decrease their compute usage there?
Yeah, and like you said, it's gotten a lot more expensive. And if you watch my next presentation, about half of the thing was based upon this whole concept of showing how much it's gone up and just what you can do to reduce that. And there's a couple strategies we've seen with customers. We've helped them adapt, or some other things we've just worked on and experimented with and seen these work well. One of the large ones, which unfortunately became a very controversial subject that I brought up at my next presentation, is actually on taking your compute and putting it where it is best for you, that may be a better fit than BigQuery. So that may be cheaper, or it may be it's a better place to put it. So for instance, one example that I've seen is a lot of customers are doing some ETL work. Previously, they've done the work in BigQuery. Maybe they're using DBT or something along those lines, and that does all DBT and tools like that do all their compute in BigQuery. But that may not be the best place for it. I mean, some customers may realize, wait a second, I already use Dataflow. Why don't I just do it in Apache Beam here in Dataflow? I can do my transforms and then load the data. And one other method I mentioned as well is that if, for instance, you are loading a ton of data, maybe you're doing a lot of merges and everything else, which are extremely expensive on BigQuery, is maybe consider doing that like on Cloud SQL or something else, that you're loading on your data, doing all your inserts, your upserts, your merges, your updates there, because that's very expensive on BigQuery, both computationally and price-wise. And maybe your data is more relational, which happens to a lot of customers, and load it into a relational database on Cloud SQL, do your work there, and then just load it into BigQuery. I mean, that's a very common practice that's happened. And in general, it is cheaper, but it also may be more efficient for your workflow because you're putting it into a more performance system for your workload. So that's just one of the big ways you can do that. And I know it's kind of controversial because it reduces your costs in many cases, but you know what? It reduces your costs and it's a more efficient way of doing it. Maybe another step of complexity, but it will reduce those costs, which everybody's looking at right now.
So you had the nerve to go to a Google Next and present BigQuery and say, number one, it's probably not the right use case. You don't have enough data. And number two, you should be using a different database instead of this data warehouse.
That's one way to put it. Well, I mean, I did preface this with saying is that this is a more efficient use of resources, and that
I get what you're saying. It's just an interesting a place to deliver that message,
Oh, agreed. I mean, it was just I kind of took the approach of here's what's best for the customer, which may or may not be the best.
We probably should have brought the dolphin filter, the dolphin swearing filter to the backstage while you were performing.
Exactly. I kind of wish it had been back there, but it's just a lot of customers came up to me afterwards and were just like sitting there like, these are actually some really good little points here. And then a lot of them just realized that they hadn't thought about things like this. And I mean, Google, I know, was not very happy because I'm sure a lot of customers implemented some of this and actually reduced their costs. But because a lot of customers hadn't really thought about this. They'd been BigQuery, and thinking that's the end all and be all. And then when these prices changes came in, they realized that my prices are going up 2x. I need to think about something out of the box to reduce these costs. And that's just the way that this works. And one tool I'll kind of put in a quick little blurb about another strategy that I didn't bring up there that I'm actually working on a blog entry with, which is if you have like Looker or a BI tool like Tableau, Tableau or Looker are the two big examples I can think of. And especially Looker, because Looker hits BigQuery a lot. And if you use Looker, just go look in your billing and see what service account hits your BigQuery the most. It's probably going to be Looker. And because of that, you're going to be using a lot of compute resources, a lot of reads. So depending on how you're doing BigQuery billing, it's going to cost you a lot of money. And a lot of times when you're doing these visualizations, you're looking at a certain period of time, generally 60, 90 days. You're not going back a lot in history. So one thing to consider is maybe loading that data into something more performant and that can actually be cheaper to query, that you can kind of use as a cache. And I'm writing the entry on how to do this, mostly looking on ClickHouse, which is a very performant data warehouse service that when optimized can, just blow the pants off of BigQuery query-wise, just because of the way they do data. But as a side effect is you just use that as a cache and store X amount of data there, so you're querying it so it's faster, but then you keep your actual data store in BigQuery, which is a strategy that's worked pretty well for a couple big customers I've worked with. So that would be something to look at, and that should be out here hopefully early December. So when that hits, take a read, and it'll give you some other perspectives and kind of out of the box on ways to think about this.
We'll include that in the episode notes for sure.
Maybe one more easy approach, let's say, one of the trust Google approach and just enable a featuring approach. So not enabling an API only, but only enabling a feature is the feature called the engine. So we've seen price increases for storage, or not storage individually, but we've seen price increases for compute specifically, but we haven't seen a price increase for BI engine. I think BI engine is still a hidden gem. It's still hidden. People often don't understand the service because it's kind of a black box. You have to trust and enable and buy capacity, and then the capacity looks pretty expensive in the first place when you just have this slider, and then it's suddenly a couple of thousands of dollars. But honestly, I recommend customers that are using BI workloads, and as they mentioned, Looker, but it's not only applicable to Looker. Basically, everything that is a SQL query that is coming from an API, it could be Looker, it could be also Tableau, could benefit from the BI engine, because the BI engine is basically another query execution engine, and it has a different pricing model than the traditional compute or the traditional slot-based model. So if your workload is kind of a BI workload where you're just aggregating data over a certain period of time, which is not transforming data, and I think this is very important here because BI engine has some limitations around the number of joins, the type of joins that are actually possible, and so on. So if you have like very specific in data engineering perspective here, or data engineering terms, you talk about so-called data marts, data product tables that are specifically white tables already that don't need to be joined anymore. If this is your type of data that you deal with, look into BI engine. and try that out, because that's something that so far hasn't seen a price increase, being honest here, but is still something that is in BigQuery as a feature and can be used quite easily. It's something that you turn on and then see cost reduction immediately, which you don't see that often these days.
Yeah, these are some hidden gems that you're sharing, and I think some of the ones I remember from the previous webinars and things that we've done in podcast episodes and Q&A sessions. We did a lot of BigQuery this year. Things like setting quotas or setting caps on your autoscaler if you're using additions. Even moving or being strategic with what resources are in which projects, so that you can have certain projects be on demand and certain projects be on addition. So kind of organizing your resources in such a way. Are there any kind of other low-hanging fruit from the BigQuery side of things, especially specifically compute? Because right after this, we'll move on to storage next.
Especially for customers or people that start using BigQuery, not only as a person, but as a team, as a company. One of my tips, or how I call them, is the dashboard of shame. So that's something you could build quite easily. It's basically a list of all the queries that have been executed, including the user that was executing the query. And the third column is slot hours or dollars, basically. How expensive was this query? And then order this in a descending way and put this on a dashboard and send it around daily, weekly, however you want to handle that. And the reason why I call it shame is because it's also educational, because you want to figure out what are bad queries, and you need to have emphasis in your team. Everyone needs to understand what is a bad query, what is a good query. And honestly, I think this helps to drive awareness within the team to see how often and how expensive queries are actually being run, and putting this on a dashboard and maybe just try it out for a week or a month or so to just drive awareness within the team. That's my number one tip for customers actually starting with a data warehouse. I mean, you could also use that for Snowflake, probably all data warehouses or all tools that are basically on demand, where you don't have the grip on the costs in the beginning.
It's big FinOps energy right there, making the data available. But I would add one more thing to that. Wouldn't frequency also be one of those things you looked at? Something that costs $5, but it's being executed 300 times. It might be more important than something that's executed 10 times and it's $10 a query.
I guess we have a widget in BigQuery Dance for that, right?
Yeah, I was setting you up for that.
I think Matan, you're quickly going to become the guy that all the data engineers listening hate if you keep giving them ideas on this.
Well, take some of that blame off Philip. I second that opinion. Yeah, definitely. I mean, I'd recommend use Data Studio, or it's called Looker Studio now. Just make a quick one that is maybe emailed out weekly. I mean, it would, or maybe top 10 offenders or something. I mean, it'd be a real easy way to do that. And you just look at the information schema, all that data is there for jobs and how much they spent, and you could easily jump through it and build a quick query.
This will be the last time I plug anything product related on this episode. I know another common best practice is setting per project quotas, at least when you're on demand.
Yeah, that's definitely, especially if you've got analysts, it's good to make a project per analyst, because the quota can only handle all users in a project. So that's the trick right there with it.
But I know we are kind of exposing BigQuery audit logs to our customers. And so using our own console, they'd be able to set per user alerts, at least not quotas, but at least alerts when individual users cross a certain dollar amount. So that will soon be available, probably will be available once this episode is released. So that's kind of a new twist on quotas and monitoring that you can't really do in BigQuery today, as far as I understand, per user monitoring.
That's correct.
For other tips and stuff, I'll be sure to link to prior episodes and webinars. So I want to make sure we have enough time to cover the other topics. Let's jump into storage. In general, I'd love to know more about just storage strategies, because storage is a portion of BigQuery, a BigQuery spend if you're storing in BigQuery. And of course, there's other storage services you can use. Why don't we start with first the new compressed storage? We'll talk about that a little bit, and then we'll move on to non-BigQuery options like GCS, Google Cloud Storage, and what you can do there.
Sure. Let me take compressed storage first. I think it's for Google, I would say probably not anything new. They've probably done that for years on their side. They've been compressing data on disk probably forever. But I think the new twist here is they actually let customers benefit from the fact that they are compressing storage. So what they are doing is basically offering physical storage, compressed storage pricing that is cheaper, or it's actually based on the compressed bytes rather than the bytes that are actually on your tables. And there are some twists or some limitations when you can actually, or when you are eligible for that. But I think in general, it's we have some queries on GitHub for that as well. There is definitely some ideas around when it's going to be cheaper and when it's going to be more expensive. There are some limitations in terms of data retrieval. So they basically made it a little bit more complex rather than offering like a 50% discount on storage. Basically, there's some strategy to look into that. But I think for especially data that is not changing that often, there is definitely or data that you don't have to retrieve that often, let's say, let's phrase it that way, compressed storage or physical storage pricing is usually a good fit. But yeah, I think this is something great to look into. Just yesterday, I had a customer just reaching out to us, and he would probably save. I mean, it's a large deployment, anyways, but he would probably save something like $6K a year just on storage by just enabling the so-called compressed storage. It's an opt-in feature that's very important. So it's not active by default. And you can basically just turn it on by running the SQL command using the API. And that's something that you activate on per dataset level. So you still have the option to keep some of the data or some of your datasets on the traditional, on the standard pricing model that is per logical byte, versus some of your datasets could be there on physical storage. But there is some math to run before you activate that feature. But yeah, generally, I think it's a good approach. The market has been offering that for some years already. So I think it's just being feature priority with the market, basically.
When would you use Google Cloud Storage instead? When would you shift to GCS?
If you have data you very, very rarely use, that say, I mean, I think a lot of customers we see are like 90 days and older data is just very rarely queried. And at that point, you could drop that to GCS on one of the colder storage classes, so you'll pay significantly less for storage. And it's sitting there and it's just not being used. So you're paying less for it, but it's accessible when those few times a year or every couple of years you need it.
I think additionally, keep in mind that there is something like auto tiering as well. So after 90 days, data becomes less expensive if you don't modify the data. This has not been changed, and this is also still the same for physical storage pricing. So just to be very clear on this.
Yeah, just to note that if you go to like something like Coldline or Archive, it is a little bit cheaper than BigQuery storage. So if you pull it once a year, it may make sense to move some of your data to GCS and put it in like archive storage, which you'll pay a penalty to retrieve it, but your storage costs are next to nothing. So it's a balancing act.
But if you're using multi-region, does it change? It changes things.
If you're using multi-region, it can be more expensive. It's usually better to drop it into a single region for the storage. And so if you need the data redundancy, it's probably best to keep it in BigQuery, just because they've got the controls for your backup of your storage.
While we are talking about multi-region quickly, because this is also an informational podcast, right? Keep in mind that multi-region on GCS is different than multi-region in BigQuery. So multi-region in GCS actually means the data is being replicated between multiple regions, while multi-region in BigQuery means BigQuery chooses the location for you somewhere in a data center where they like to store it, probably where they have less capacity or more capacity or more free capacity, but it's actually not data that is being redundant, or what do you say? Like, it's actually not being replicated across multiple regions. So if you've been a multi-region and you want to export to GCS, a single region is probably the same data localization strategy as it was before, but it was just labeled differently. Multi-region in BigQuery is just a single region on or back in the hit.
Yeah, and the same goes for compute as well. It's not just storage on that. And after in Next, I was told by a BigQuery PM that if you do that in the U.S. multi-region, there's about a 95% chance your data will be in U.S. Central 1, just as a note.
The topic of regions, I recall even more recently, another case of what is this SKU? And I think it had something to do with networking traffic. If we're jumping from storage to networking right now in the context of a data platform, some SKU that around networking that many customers were confused about. Maybe you could shed some light on that.
Yeah, so this came out, it was like September 15th, and this was a really kind of under the radar kind of announcement. There was literally a page put up about this that one of my colleagues found and mentioned to me, and I was kind of surprised because there was very little information. But it's called General Egress Networking Traffic for Google Cloud Cross Region. Yeah, don't try to say that one fast, but it's a super long name. And essentially, it's BigQuery egress costs across regions is what it is. And so if you're doing any sort of copies of data from a US multi-region or any multi-region to a specific region, it's going to incur costs now. A lot of customers didn't know this was a thing, and there's really no way to test if you were doing it or not because the SKU didn't exist. But as of September 15th, they started doing that, and this SKU started appearing for some customers. And that's actually been brought up to us a couple times. Customers are like, what is going on here? And so it just means you're transferring data across. So like if you have something in the US multi-region, and maybe you're backing up to US Central 1 or US West 1, and you're doing just a copy, that would incur that cost. But one of the other things is if you're doing certain operations, which I believe is just moving data or pulling data, doing extracts, it will happen if your compute resources are in a different region than the data set. So big example I saw with one customer that we were figuring this out was they had an Airflow DAG or running on Cloud Composer that was in like US East 1 or something. And they were pulling from a data set that was in the US multi-region. They were doing some extracts and a couple other things. And I think the extracts were going to GCS, if I'm not mistaken. And it was in a whole different regional bucket. And they were pulling it across, and they were incurring this fee because the resources were in a separate region than where the data set was. And that was pulling it. Now, how do you know you're doing this and you see that SKU? The one thing I've discovered it's really easy to do is kind of look at your billing data and look at your SKUs. Do you have data stored in a multi-region and in another region? If you got, say, in the Europe multi-region, then you're putting it in EU West 1 is a specific SKU saying storage here. That means you're storing data in both of those, and there's a good chance you're running compute or you're doing copies between those, and that's probably where it's coming from. And that's been kind of the only real way I've discovered to be able to determine that's what's going on here. There's really not a good method of going and looking and saying, oh, we can run a query and do that. Unfortunately, it's really hard to track down. So if you've got SKUs from multiple regions on storage, there's a good chance it's happening between those two regions.
In general, it's now a good rule of thumb to minimize the footprint of regions, right? To keep the regions that you're only needing because your data protection officer is saying you have to store data in that specific region, or because your data is being inserted there because, for example, Google Analytics is always per default in the US, unless you explicitly change that. But I think a good way of actually preventing that is using org policies in the long term. So reducing the locations that are restrict the locations where you can actually store BigQuery data to the very minimum of available locations, because then also the chance of egress is also being minimized to the minimum.
I'm just going back to what you were saying there about selecting the multi-region and putting a few of those things together. And maybe I'm misunderstanding, but you can't choose. You choose multi-region. You can't necessarily figure out where it's going to land. There's a good chance that it'll land in US Central 1, as you mentioned. But then you just start getting these charges for network traffic that you didn't expect, didn't realize would happen because of just where Google have chosen to place resources for you. Does that not defeat the whole purpose of choosing something like a multi-region, and then you're better off just saying, I want explicitly there, or does multi-region give you some other...
is cheaper.
It's
multi-region
cheaper,
is cheaper.
Cheaper because they can charge you on the data.
Yeah, correct. Because they probably charge you basically, or they can figure it out where it's cheaper for them. I had customers remembering the Paris incident last summer, I think, or this summer, I don't remember.
Summer, yeah.
Basically, they complained, oh yeah, we have no access to data anymore, but it's in multi-region. You would think like multi-region is being replicated, right? But under the hood, it was in Paris. It wasn't a single disk in Paris, and nobody figured it out because it's being labeled as multi-region. But basically, Google put it in the Paris data center because it was pretty new. Probably there was some excess storage available, and it was cheap for them, right, to store it there. So that's why they offer it cheaper than a specific region, actually.
I'm gonna need that dolphin sound, Matan.
The good thing about BigQuery is it defaults to the multi-region of the area of the world you're in. So if you're in Europe, it's going to go to the EU multi-region. If you're in America, US, or North America, it's going to go to the US multi-region. You have to literally specifically go and do a drop down to say, I want to put my data elsewhere, which unfortunately a lot of customers do and think, oh, I'm in the Washington, D.C. metro area. I want to choose the one that's nearest me, which unfortunately is one of the most expensive regions. Or the Paris one was apparently the same way from what I heard from other customers, that they chose that because it was nearest to them. And unfortunately, things like this happen. And those are also two of the most expensive ones. So whereas Google, they choose like the U.S. multi-region, which is in Iowa, which is actually outside of Des Moines, Iowa, which if you've never been to the U.S. in the area, it is nothing but cornfields as far as the eye can see out there. Literally, you're driving down the road to the data center. I did it last summer, and it's just cornfields around this entire thing. It's nothing. So it's very cheap for them to put all their resources there.
On the topic of, I guess data ingestion, we talked about, maybe you should perform ETL externally, but are there any other things around data ingestion for talking about the whole world or realm of the platform, not just BigQuery and not just storage? Are there anything else in terms of data ingestion that customers should consider when building a data platform with BigQuery in the center of it?
And one thing I would mention, just not for BigQuery, but for data warehouses in general, I would say that pre-calculate as much of your data as possible when you're putting in, just because doing anything in general, doing any calculation beforehand makes it a read later instead of a read, calculate, read, and write. Just in general, if you can do if there's any calculations you can do in advance. And that's a big thing we see with BigQuery. I mean, it's going to be a problem with Snowflake, with ClickHouse, DuckDB, any of the others out there, is if you're storing data, it's a read. If you're needing to calculate data when you're doing a query, it's a read, it's a calculate, possibly multiple calculations, and then it's writing into a temp table, and then you're reading it again. So just something to think about is do as much as you can beforehand to keep your house in order to make it easier to clean later, essentially.
I've even seen cases where it would make sense to store data, like the source data being in GCS still. So you have an application that is writing not directly to BigQuery, but that's just writing like Parquet files or Apple files to a GCS store. And then you have a batch import that is probably running once a day or so. That is just collecting those Parquet files and importing them. That would be also a strategy, for example, if data changes within the day and you need to reconcile data, you just have to touch the Parquet file and you don't have to go into all the BigQuery rows and read that before and then do the updating and the DML statements there. So sometimes if your application works better with the GCS bucket, that could be also a good strategy to keep the landing zone actually on GCS and then do a batch import just from there. Because keep in mind, importing into BigQuery is always free, but changing the data then afterwards is not only costly, but also then from a performance perspective, changing a record in the landing zone within BigQuery would also incur costs and net performance.
Let's see, anything else we should cover that we missed in terms of the data platform? Maybe do you have like general tips if we're thinking about high level, tips for building a really good data platform, just overall strategy around that? Doesn't have to be service specific, but
Sam would probably agree with that. But my strategy is have cost monitoring from day zero. I mentioned that because of knowledge and education perspective first, but because platform grows over time and then you forget about it. So better have like cost monitoring from day zero, and then optimize. It doesn't need to be perfect from day zero, but at least have something in place, have some automation that is checking, better than nothing.
And to follow up on that, I would also say labeling, which we have a labeling blog that I wrote a couple of years ago and actually had to update it earlier this week because a couple of the links were broken from us changing our platform in all of our links, and went back through it and kind of added a few more points. If you can, label everything you can. I mean, services, data, anything like that, and put in your label saying like this is for this workload, this is for this application, this is this group of users. Because when you go into your billing console, or if you're a DoiT customer, the DoiT console, you're able to sort by those labels and search by them and say, I want to look at workflow 1, 2, 3. You can pull all the costs associated with that and see how much is this particular workload costing you across the entire thing. And it's pretty easy to have. And once you got it set up properly, it makes your reporting so much easier. You can tell your costs. And when you need to go in and say, I have a cost spike on this, you're able to see, oh, that came from me running this ETL job yesterday. It ran significantly higher than it should on that day only. And you're able to see it very easily. So definitely from day zero, implement those, do labeling, do anything you can to be able to monitor and observe your costs.
It's almost like you guys have been listening to my FinOps rants all this time. It's great.
You gotta keep
I should try those FinOps certifications, right?
Definitely. I'll talk to you about it later.
The last thing, actually, I didn't label queries in BigQuery until you told me a couple of months ago, Sal. But maybe talk about that as well, since you mentioned labels.
Sure. Yeah. Labels. You can put labels on data sets and tables real easy. It's just the console. There's a little thing you can put on there. Unfortunately, queries, they're a little bit more difficult. There's not a way, if you're an old C or C++ developer, did some of the older languages, there's things called preprocessor directives. You're able to put little hash sign followed by something to tag or do some data. It'd be nice if we could do something like that and say, put a label on this query while it's in line in the SQL. But unfortunately, Google doesn't allow that. They only allow labels if you're calling it through the command line or the API, which I'm sure the command line calls the API behind the scenes. So you can apply a label then. So if your application or anything you're doing, or if you're doing CLI queries, you can put a label on it. And I would highly recommend doing that just because it'll apply that label to that query. And at that point, you can say, give me label XYZ and see how much that thing costs, whether it's your analysis cost or your slot cost. It'll tell you based upon that query by just looking at that label.
Looker and dbt Cloud, for example, they label every job on BigQuery automatically. So that's already something nice. You can basically go by invocation ID from a Looker query to figure out what that current cost was, but also for each dbt job that is being invocated on BigQuery side, it also has a specific ID.
Yeah, and that's a good point about Looker, because Looker is probably one of the most expensive BigQuery ancillary services out there.
I think that's enough BigQuery information to, I don't know, satisfy the thirst of all the data enthusiasts out there, the data analysts. It's a lot of knowledge drop. Even if you include the 3 other webinars and episodes that we did on this. So thank you, Philip and Sale, for joining us. Don't worry, Sale, we won't take this episode down the day after you.
Thanks. You may want to put a note in there while you said that comment.
If anyone gets, if they listen this far, then I think that says a lot about the content itself. So, Easter egg at the end. Yeah, thanks for joining us, guys. And this probably won't be the last BigQuery related or data related webinar or podcast episode that we do with you guys. So, thank you, and everyone, stay tuned for the next episode after. Bye, everyone.
Thanks, everyone. Ciao.
Cloud Masters is a DoiT multimedia production, hosted by Matan Bordo, a product marketing manager at DoiT, and Sam Clark, a technical account manager at DoiT. Our guests this week were Philip Heinrich and Sale Matthews, 2 senior cloud architects and BigQuery experts from DoiT. Editing and production of Cloud Masters is handled by me, Crispin Stanbeck, multimedia content producer here at DoiT. To hear more episodes of Cloud Masters, and to learn how DoiT delivers the true promise of the cloud with ease, not cost, visit doit.com.